Hello everyone. I'm Sachin Kapoor from College of Technology, Pandit, India, and today I'll be talking about building zero trust security infrastructure in Rust. I will walk you through what zero trust means and some of the fundamentals of it, what advantages Rust bring to this problem. We'll also go through some of the building blocks Rust provide to build a secure infrastructure. Then we'll look at some implementation patterns and close with some performance numbers from real-world implementations. Let's start by looking at zero trust security fundamentals. In today's threat landscape of sophisticated threat actors and now advent of AI, we have to always assume a breach scenario for any system infrastructure. This pushes us to lay down some ground rules for zero trust. First and foremost, we cannot trust without verifying the ID of any component. Always design access using least privilege and have a very high standard for monitoring and validation to detect what's happening in your ecosystem. Now, with the background of what we intend to achieve, let's see what Rust has to offer when it comes to security. First and foremost, systems built using Rust gets the advantage of Rust ownership model, which prevent memory vulnerabilities like buffer overflows and use after free. This is a big trust advantage for systems built using Rust. Rust also provides predictable performance, which helps with real-time security decisions using metrics and other telemetry the ecosystem provides. Next, let's talk about Rust string type system, which helps perform compile time checks for critical controls like authentication. Another advantage of Rust is the security abstractions provided by the language for fast and effective operations when it comes to cryptography, authentication, and authorizations, which is critical to build a secure ecosystem. Rust safety guarantees and performance characteristics makes it as ideal choice for a zero trust architecture implementation. Now let's dive into some of the components which will help us build for zero trust. These Rust components are the building blocks of foundation security and helps developers and security engineers achieve their goals. I have broken these components into three categories. First, networking and TLS. Tokyo, Rust TLS, WebPKI, and Quinn helps developers build for secure channel implementation with high performance and memory safe TLS implementations. On the authentication and identity side, Rust Ring and Argon 2 provides the primitive for strong authentication. JSON Web Token and OAuth 2 RS components help build industry standard authentication mechanism with ease. Last, but one of the most important aspects of security infrastructure is default network libraries and observability capabilities. HyperInt Tower provides a robust networking stack, while tracing and metrics provides rich performance and diagnostic data for a solid foundation for monitoring and detections. We just talked about how you can use some of Rust core components to build a secure software stack. Now let's talk about a critical component of zero trust architecture, and that is entity-aware proxies. As I mentioned in my opening, one of the fundamentals of zero trust architecture is verifying the caller and perform fine-grained authorization decisions and also enforce policy based on context. Rust provides a perfect ecosystem for such architecture implementation, with components like Tower as a middleware choice. Also, Rust Trade System is a perfect choice for a type-safe policy implementation, which also enables compile time verification of policy logic, providing very high security assurance for policy checks. And best part is there are no runtime surprises. We touched on the importance of observability for a zero trust architecture. Rust metrics and tracing libraries makes metric data gathering a breeze and comes with a high performance benefit which enables almost real-time analysis of metric data for faster detections without penalizing the performance of our applications. Anomaly detection becomes so much better when you use metrics data in Rust. Now let's dive a little deeper for the secure communication implementation in Rust. As I mentioned earlier, Rust TLS is a great candidate for memory-safe TLS implementation, which comes with high performance and eliminates a whole suite of vulnerabilities which can be found in other TLS implementations. Definitely a big win here. Web PKI ensures that certificate validation for secure communication is per RFC standards without a risk of wrong configurations and possible authentication bypass vulnerabilities. And Quinn adds the cherry on top. If you want to implement quick protocol for higher performance and security, I would highly encourage to have a look at that. Overall, Rust's library ecosystem offers strong typing, compile time detections of errors, makes it a perfect choice for implementing error-free and robust secure communication platform, and fulfills the foundation needed for a zero trust system. Now let's dive into the complex world of supply chain security, which has caused some of the biggest breaches of our times. You must have definitely heard of SolarWinds and how a third-party vulnerable system can compromise security of overall secure system. Rust cargo ecosystem ships with all the tooling needed to maintain secure dependencies and ensuring supply chain vulnerabilities are accounted for while building the environment. Definitely an amazing advantage and makes supply chain security management less complex to implement. Let's quickly look into some of the performance characteristic of Rust implementations, as there is often a concern that security comes with a performance price. As you can see that Rust high performance on JWT validation with a latency of just 0.3 millisecond, ability to make concurrent secure connections at a high scale, and the, a high availability provided by no GC pause and memory related crashes makes it a perfect choice for implementing components for zero trust architecture. Trust Proxy is a perfect example of such an implementation. I would highly encourage to look at Cloudflare's Pingora for such an implementation and how Cloudflare has achieved higher security and performance at the same time and providing the best-in-class proxy for its consumers. Let's talk about some of the key takeaways from my presentation before we close. Rust brings a lot to the table when it comes to building security-sensitive workloads critical for zero trust. First, compile time enforcement is a superpower when it comes to security assurances. Second, you don't need to compromise on performance. And third, the ecosystem continues to mature when it comes to security focused implementation. And there is a lot of open source contributions in this space. I will highly encourage all of you to evaluate your current stack for bottlenecks related to authentication performance, secure communication performance, and also vulnerabilities in those stacks, and evaluate Rust for those needs. I'm sure you'll not be disappointed. Thanks for listening my talk, and I wish you best in your security journey.